Okay, up to now, we discussed how data is shared across the systems. But when systems become distributed, we cannot guarantee everything at once. Again, we cannot guarantee everything at once. There is no any ideal system without any doubt, without any bugs or errors. This leads us to CAP theorem, which is CAP theorem we usually call it. Explains trade-offs between consistency, availability, and partition tolerance in here. So we can see in here these 11 diagrams, and firstly we can see consistency, that it guarantees that all nodes in distributed system returns the same most recent data simultaneously, ensuring every data read operation receives the latest write. So it means the rule that all nodes see the same data at the same time. After write, every read gets the latest value, no outdated data. So the next one is availability. It means that every request received by non-failing node in a distributed system must result a valid non-error response, even if some nodes are down or communication is partitioned. So the rule is the system always responds to request. Every request gets a response even if the response is not the latest data. So the last one is partition tolerant. It refers to distributed systems' ability to continue operating properly despite network failures like partitions that break communication between nodes. It means in a simple way, system continues working even if no networks fails between nodes. Nodes cannot communicate properly. System cannot be sleepy. So, on the other hand, we have some combinations. Like we can combine these three concepts, CA, CP, and AP, some different ways. As we can see that Euler-Venn diagrams and include CA, CP, and AP concepts. So firstly, CA means consistency and availability. CA systems provide both consistency and availability, However, they assume that there is no network partition, so they work well only the systems without network failures. This type is rare actually in the distributed systems because network issues are unavoidable. For instance, single server database, also the same typical examples. It means CA greater than partition tolerance. The next one is CP, consistency and partition tolerant. CP systems focus on the consistency and partition tolerance, and it means the system always returns, of course, correct and updated data. However, during the network failures, it may reject requests or become unavailable. It means the simple term, it is better to stop the system rather than return wrong data. For instance, we usually use it, or not only we, the distributed systems, and we usually use the banking systems, which is the ACID-based systems. And this model, because correctness is very, very important. That means consistency and partition greater than availability. And the last one is AP. That system focuses on availability and partition tolerance. And that means system always respond to requests, even during network failures. However, data may not be able latest. It can be temporary inconsistency. In this case, it is better to respond with possibly all data than not respond at all. For instance, social media platforms like the YouTube or Instagram, and there's view counts, for example, and like counts as a real examples. So availability and partition greater than consistency. We usually call it, for example, eventual consistency, also the second theme is. So overall, the CAP theorem system tells us that distributed systems, during the network failure, we must choose between consistency, availability, and partition tolerance, and it depends on our business requirements.